Hello everyone, this is Hymavathi, working as an assistant professor in the Department of Humanities and Science, MLR Institute of Technology. So in the last session, we discussed about the method 4 of finding a particular integral. So today, we'll discuss about the method 5 of finding a particular integral, and we'll see the problem on that type 5 or the method 4. So now see what is the type 5 or the method 5 of a integral type. So when q of x is equal to x into v of x. So where v of x is any function. So where v of x is any function. So mostly we are taking here the v of x is sin ax or cos ax. Suppose if the v of x is e power ax. Suppose if v of x is e power ax, so then directly we can use the method 4 to find the particular integral. So here the v of x is sin ax or cos ax. So if it is the sin ax or the cos ax, then how can we find the yp? The yp defines 1 by f of d into q of x, where q of x is x into v of x. So to find the yp, this is the formula, that is x minus 1 by f of d into f dash of d into 1 by f of d into v of x. So here v of x is a sin ax or cos ax. So 1 by f of d into v of x, if it is sin ax or cos ax, definitely we have to use the method 2 from here. Then later you have to multiply with each and every term, and again we are using the method 2 to find the yp. So what is the yp of method 5 is x into v of x is the method 5. So if it is q of x is x into v of x, the yp is x minus 1 by f of d into f dash of d. We know that what is f dash of d, it means nothing but the derivative, into 1 by f of d into v of x. So this is the method 5 of finding a particular integral. So now let us see one problem on the method 5 when q of x is equal to x into v of x. Solve d square plus 2d plus 1 into y is equal to x into cos x. So now this is of the form f of d into y is equal to q of x. F of d into y is equal to q of x, where q of x is x into cos x. X into cos x is nothing but obviously this is the method 5. So now to find the general solution, first we required a complementary function. So to find the complementary function, yc is, first you have to take the auxiliary equation. The auxiliary equation is m square plus 2m plus 1 is equal to 0. M square plus 2m plus 1 is equal to 0. This is nothing but m plus 1 whole square is equal to 0. M is equal to minus 1 and minus 1. Then the complementary function is here the repeated roots. So yc is equal to c1 plus c2x into e power minus x. So this is the complementary function. So now to find the yp. So to find the yp, 1 by f of d into q of x. So here f of d is nothing but d square plus 2d plus 1. Q of x is nothing but x into cos x. So this is of the form x into v of x. So where v of x is nothing but cos x. So if it is a cos x means definitely we have to use the method 2. So here the formula is x minus 1 by f of d, that means d square plus 2d plus 1 into f dash of d. The derivative is 2d plus 2 is the derivative into 1 by f of d is d square plus 2d plus 1 into cos x. So this is the formula of yp when q of x is x into v of x. So this is x minus 1 by d square. So this d square plus 2d plus 1, we can write this as d plus 1 whole square. The numerator take 2 common, 2 into d plus 1, right? So here now you have to use the method 2. Method 2 we have to apply. So if it is a method 2, then what is the substitution to take? Here the substitution is d square is equal to minus 1 is the substitution. So 1 by minus 1 plus 2d plus 1 into cos x. X minus, so here you can cancel with one time, 2 by d plus 1 into, so here the minus 1 and plus 1 is cancelled, 1 by 2d into cos x. So we know that d stands for differentiation, and here 1 by d stands for the integration. X minus 2 by d plus 1 into 1 by 2 into integral cos x dx. So since 1 by d stands for integration, so x minus 2 by d plus 1 into 1 by 2 into, we know that what is the integration of cos x? Integration of cos x is nothing but sin x. So now multiply with the each term, x sin x by 2 minus 2 by d plus 1 into 1 by 2 into sin x. So here 2 gets cancelled. X sin x by 2 minus 1 by d plus 1 into sin x. So now see the second term. This is the second term. For the second term, again we have to use the method 2. X sin x. The method 2 is, what's the substitution to take? D square is equal to minus a square. So here the a square value is 1. The d square is minus 1. So but here in the denominator, so we don't have the d square. So that use the rationalization. So multiply and divide with d minus 1. So d minus 1 into d plus 1 into sin x. X sin x by 2 minus of d minus 1 into sin x by d minus 1 into d plus 1 is d square minus 1. So now here the substitution is d square is equal to minus 1 is the substitution. X sin x by 2 minus of d minus 1 into sin x divided by minus 1 minus 1. Minus 1 minus 1 is nothing but minus 2. X sin x by 2. So here the minus 1 is minus 2, and before we have one more minus. So this is plus. So then now multiply with the each term, d sin x minus sin x. X sin x by 2 plus d stands for the differentiation, right? We know that d stands for the differentiation, right? We have to do the differentiation on sin x. So what is the derivative of sin x? Derivative of sin x is cos x minus, so anyway we have the sin x, that sin x also we have to write here. So this is the yp of the given function. So now we have to write a general solution. So what is the general solution? The general solution is y is equal to the complementary function. So what is the complementary function? So this is the complementary function. C1 plus C2x into e power minus x plus minus x plus x sin x by 2 plus cos x minus sin x. So this is the general solution of the given differential equation when the q of x is x into v of x. So if v of x is equal to cos x, so then you have to use the formula. What is that formula? So this is the q of x. So what is the yp? The yp is x minus 1 by f of d into f dash of d into 1 by f of d into v of x. So if it is the v of x is either sin ax or cos ax, then you have to use the method 2 to find the value of 1 by f of d into v of x. Sometimes v of x is e power x also. If it is an e power x, then you can go for directly the method 4 to find the particular integral. So this is all about the method 5 of the particular integral. So now in the next class, we will see the other topic, that is the method of variation of parameters to find a general solution of non-homogeneous linear differential equation with the constant coefficients. Thank you.